everyone, and welcome to another episode of Eyes on Earth. Our podcast focuses on our ever-changing planet and on the people at Eros and across the globe who use remote sensing to monitor the health of Earth. My name is Jane Lawson, and I'll be hosting today's episode, where we're talking about how Landsat is helping identify urban heat island areas. Urban heat islands occur in urban areas containing more impervious surfaces like pavement and buildings, and fewer natural environments like trees, grass, and water bodies. The day and night surface temperature is higher in urban heat islands than in surrounding areas. During heat waves, this can lead to greater numbers of heat-related illnesses and deaths. Landsat satellites have collected data on surface temperature and vegetative change for decades. Knowing where a city's hottest spots are now and the trends over time can help leaders make plans to mitigate the heat stresses for residents, especially in a warming climate. Our guests today are here to talk about how their urban heat island work has intersected with Landsat data. Christian Branyan, who earned a PhD in civil engineering at Georgia Tech, researches climate change-related issues and currently works with NASA's Goddard Institute for Space Studies, as well as serving on the New York City panel on climate change. James Catone is a resiliency planner with the Land Use Division at the New York City Council. Dr. Branyan, James, welcome to Eyes on Earth.
Good morning.
Good morning. Thanks for having us.
So first off, Dr. Branyan, do you want to tell us a little about urban heat islands and how they can be a threat to human health, especially in a future that may include more heat waves?
We're certainly expecting more heat waves in the future in places like New York, more frequent heat waves and heat waves of longer duration. But the heat wave that the city of New York experienced as a whole doesn't reveal the whole picture. Cities tend to have concentrations of pavement and concrete and roads and buildings. These built materials absorb shortwave radiation. They're storing that as heat, and then they're releasing it as long-wave radiation during the day and at night. And so there's this tendency for cities, for places with lots of built-up materials to be warmer than their rural counterparts. Some places in the city are actually hotter than other places in the city, and those folks will be experiencing more extreme heat. This is a huge concern because you may have folks that are more vulnerable to heat in those areas. And we know that folks will die sometimes during heat waves, and they may be hospitalized, or it certainly might impact their quality of life. Heat waves are a huge concern, but the urban heat island really exacerbates the conditions that we experience during heat waves.
So how can a satellite in the sky help pinpoint which areas on the ground are urban heat islands?
Good question. Good question. So we use satellites to understand what's leaving the surface in terms of electromagnetic radiation. Sunlight will penetrate the atmosphere and hit the surface, and different materials on the surface will absorb some of that, but they'll reflect different parts of the electromagnetic spectrum, and they tend to absorb different parts. Each material on the surface of the Earth in that way has its own spectral signature. By understanding the spectral signature of different materials, we have a pretty good sense of what's going on at the surface of the Earth when we sense radiation that is able to escape the atmosphere and be detected by sensors on satellites. What we do is we actually are looking for the part of the electromagnetic spectrum associated with heat. And in doing so, we actually can map the distribution of elevated land surface temperature across different parts of Earth. A lot of the work I do is focused on mapping elevated land surface temperature in cities.
Let's talk about a city that you're both familiar with, New York. How has the summer been going so far in New York? It sounds like you had a pretty unpleasant heat wave at the end of June.
It was very hot, wasn't it, James?
Yes. The week before the 4th of July, last week of June, was extremely hot. We had, I think it was 2 days where the effective temperature with humidity was over 100 degrees. I think the Wednesday before the 4th of July, we got an alert. Everyone's cell phone kind of buzzes at the same time, and it said to, conserve energy as much as possible, avoid running washing machines, dishwashers, and to run air conditioners at a warmer temperature. We did have a few localized outages in each of the 5 boroughs, which is another one of the consequences of the urban heat island effect, and heat waves in particular, in addition to human health consequences, is increased electricity demand leading to blackouts and brownouts.
James, do you want to describe the City Council's goal in mapping urban heat islands in New York City and how that led you and the Council's data team to Dr. Branyan for guidance?
Absolutely. When I came on to the Council in 2019, my role was intended to be as a kind of subject matter expert on climate resiliency. one of the things that we wanted to try to understand was how heat risk varies across the city. We know that cities are warmer than the surrounding environment, but within the city itself, we were wondering what the distribution of heat risks was. There are only so many weather stations in the world that provide reliable historical data. In New York City, we have the ones at the airports, and we have a weather station in Central Park, which has records that go back almost to the Civil War. So it's a good data set, but it's only one spot in the city, and it's in a big park. So it's going to be somewhat cooler. That led us to looking at satellite data. I didn't have the capacity on my local geographic information systems software to be able to really work with the temperature data. And that's how I discovered, because I was still relatively new to council at that point, that we had a data science team. We spent some time looking at the satellite data from Landsat, which it's like an image composed of pixels with a single temperature reading. We were thinking of publishing this heat map on the council website as a public-facing product, and we wanted to make sure that we were putting out something that was as sort of accurate and not misleading as possible. So we wanted to make sure that we were averaging temperatures and not sending like one particular temperature reading from one particular day. I had connected with the New York City panel on climate change for part of my work previously. And so I reached out to them to ask who we should talk to understand how to work with the Landsat temperature data. They connected us with Christian.
Dr. Branyan, how did you lead them to their resulting map then?
It was a great conversation with James and data scientists about how to best use the data. Landsat is capturing data over New York late morning, and so you have to take that into consideration. It's not the hottest time during the day. It's also not at night when you might be curious about how much warmer the city is in comparison to rural areas due to all that energy that's absorbed during the day. However, it does give you a good sense for the relative surface temperature throughout the city at that time, in late morning. What I explained to James and his colleagues is that the hottest areas in the city, the locations that have, relatively speaking, higher surface temperatures, they're going to tend to always have those elevated land surface temperatures. And so the cooler spots, water bodies, vegetation, they're going to tend to be cooler. And the hottest areas will tend to stay warmer. Industrial areas, blacktops, concentrations of concrete and asphalt. Instead of just using the raw land surface temperature value, which is going to fluctuate quite a bit, if it rains on a given day or if it rains the day before, I encourage them to think about which areas tend to be hotter when you look at multiple images and which tend to be cooler. I thought that would be the better approach. That's what I'm often encouraging folks to do when they use Landsat data. And I think that they found some success and were able to create an amazing tool.
James, tell me a little about the map. Where did you find were the hottest places in New York, and how is the council hoping to mitigate those?
The map that we published shows temperature across the city as a kind of deviation from the mean temperature. We're not providing actual degrees temperature. Looking at the city, the first thing that jumped out at me was all of the coolest locations are all kind of wetland areas. They're in the center of Jamaica Bay, in Fresh Kills, which is a large wetland area on Staten Island, Pelham Bay Park, a park in the Bronx along the Long Island Sound. These are the coolest places, and that seemed to make sense to me. You have both vegetation and water body kind of at the same place. The hottest places, the first thing you probably notice is the airport. JFK is extremely hot. And that seems also kind of intuitive. It's a large area of flat pavement. The other hottest areas tend to be industrial areas with heavy port infrastructure, rail yards, large stretches of manufacturing and industrial buildings, which tend to be low slung with big rooftops and big parking lots. And then there were some surprises as well. Some of the core neighborhoods in Manhattan, Lower Manhattan, the financial district, and even Midtown, just south of Central Park, were cooler than I would have probably expected considering the intensity of the built environment there. It's very dense with lots of skyscrapers and relatively little green space. But the financial district is kind of surrounded by water on three sides. That probably helps. And since it's surface temperature, I suspected that there may be some building shadow effects at play. We definitely found that there's clear overlap in historical neighborhoods of color and higher surface temperatures. And there's some other interesting correlations that I think we still don't fully understand. Some of the areas that have high surface temperatures are relatively lower density and more suburban. Sort of southeast Queens is pretty warm. I think in the long run, what the council would like to do is propose some deeper investigation of what causes some of the disparate relative local temperatures in the city. It would be useful to know, is it because there's very few trees in an area? That seems like very obvious. But then there's some areas that if it's a lower density area, like why is it hotter? Is it because there's more driveways, more parking lots, and they'll read as hotter? One thing I should mention is that the Department of Health and Mental Hygiene in New York City has a heat vulnerability index at the neighborhood level. We've created these neighborhood tabulation areas, which are groups of census tracts that we can use as a rough approximation of neighborhoods as New Yorkers understand them. And their index includes surface temperature from Landsat as one of the component parts, as well as racial characteristics, poverty characteristics, household access to air conditioning as well. And part of the goal of an index like that is to help better target programs, tree planting initiatives, cool roof programs, free air conditioner programs. From a land use perspective, and I suppose I'm speaking more from my own perspective than the council as an institution, it would be great to have a deeper understanding of these relative temperature differences, because it seems that there may be land use interventions in the long run. Not just planting more street trees, but if you know a particular neighborhood has a particularly severe urban heat island effect, and you understood the dynamics of where you were getting solar gain and what the prevailing wind patterns were, you might say, if this avenue had a planted median, that would relieve some of the heat island effect for this group of blocks to the west of that or to the east of that.
Dr. Brannion, do you want to talk a little about your role on New York City's climate change panel and the intent of that panel?
The New York City Panel on Climate Change is an independent body that analyzes climate risks to New York City and advises on resiliency and adaptation to help ensure the city is prepared to withstand and emerge stronger from climate change. It's a team consisting of diverse and distinguished academics, researchers, and practitioners with various expertise in disciplines such as climate science, environmental studies, demography, urban planning, architecture, urban design. And we're responsible for producing science on current and projected climate trends for the New York City metro area. Climate projections are the foundation of the city's adaptation planning. For example, in engineering and design for coastal resiliency projects. I'm part of the Climate Science and Projections Working Group. I also co-chair the New York City Panel on Climate Change as a whole. And I'm really proud to do this work because previous MPCC work has really yielded very important information on the direct and indirect impacts of climate change. And so just extremely excited to contribute to the fourth assessment of the New York City Panel on Climate Change, and heat vulnerability as well as equity will be a big theme.
New York is not the only city you've worked with. You've worked with other cities around the world, right?
That's true. Yes, I'm currently doing some work with eThekwini municipality, which is part of Durban, South Africa. I've done work in Tel Aviv, Yafo, Israel. I'm also doing quite a bit of work with the city of Chicago.
As the climate changes, how important is it for those cities and others to learn about their own heat islands and consider how to address them?
You know, it's extremely important. In the United States, a lot of folks don't realize that heat is the weather hazard that kills the most people. In New York, it's a huge concern where lots of folks are hospitalized each year, and sometimes those hospitalizations aren't identified as being associated with heat, but we know that there's hospitalizations happening during extreme heat days. Some folks estimate that nearly 600 New Yorkers will deal with heat-related illness each year on average, and there's nearly 130 deaths each year related to heat. In places like New York and other regions around the world, we're expecting more extreme heat days, more days above 90 degrees Fahrenheit, more days, of course, above 100 degrees Fahrenheit, as well as more frequent and intense heat waves. So it's extremely important to use Landsat data to inform urban planning. We can be thoughtful about how we shape the built environment around us, introducing shade, introducing vegetation, green infrastructure, changing the albedo of the surface, doing all the things in our toolbox so that folks have a better experience when it comes to extreme heat.
And remote sensing like Landsat and other satellites are one of the tools in your toolbox then to coping with heat.
Yes, absolutely. You know, A lot of folks will want air temperature sensors. It would be really nice if New York and other cities had a very dense network of air temperature sensors. But those air temperature sensors are very expensive to maintain and very difficult to deploy and calibrate. And so Landsat data is an amazing resource because it allows for longitudinal studies. We can look back and understand how surface temperature is changing over time. But in addition, it's extremely important to understand the spatial distribution of heat. We really want to understand how heat is distributed in relation to socioeconomic conditions. It's not chance that some communities are taking on a disproportionate burden when it comes to extreme heat. This is due to racist policies in the past, like segregation and redlining, at least in part. And so we have this amazing opportunity to use all the data sets at our disposal to undo some of this inequity and create equity so that no communities take on an unfair share of burdens related to extreme heat.
I would definitely echo that. One of the things that we hope that resources like this can help with is trying to mitigate some of the disproportionate consequences of our history in a lot of these communities. Heat is the deadliest natural hazard in the United States. Getting closer to being able to relieve some of that is hugely important.
Thank you both for joining us for this episode of Eyes on Earth, where we talked about urban heat islands. And thank you to the listeners. Check out our AROS Facebook and Twitter pages to watch for our newest episodes. You can also subscribe to us on Apple Podcasts. This podcast is a product of the U.S. Geological Survey, Department of the Interior.